quiz tomorrow is going to be on this, simplifying radicals with multiplication division of a root, right? So it's a little number in front of the root. So if you see a little number in front, that is it's called the index. If there's no number in the front, like over here, the index is automatically 2 because it's a square root. Okay, so if there's no index, just assume it's a 2. It tells you how many buddies get to leave the house at once. So remember, for square roots, you had to have partners. You had to have 2 come out at the same time. Well, if it's a cube root, it has to be 3 at the same time, fourth root 4 at the same time, and so on. Yay? Okay. All right. So something to think about. Here we go. Take 3 to the second power. What is that? 9. Very good. Negative 3 to the second power is 9. If we do the same thing for an odd number of roots, like 2 to the third power is 8, but negative 2 to the third power is negative 8. So, the reason I show that is because, can you take the square root of 9? Yes. Square root of 9 is plus or minus. It's 3, right? Yeah. Versus the square root of negative 9 is not a real number, so it's plus or minus 3i. So you can't take the square root of a negative in the real number sense, so you have to throw an imaginary number. Cube roots, though. The cube root of 8 is the cube root of 2 times 2 times 2, right? So if you have a group of 3, then the cube root of 8 is just 2. And cube root of negative 8, right here, is negative 2 times negative 2 times negative 2. So the cube root of 8 is negative 2. Notice there's no imaginary numbers for cube roots. In fact, there's no imaginary numbers for odd number powers because you can take the odd root of a negative number. Okay, so the difference is imaginaries for squares and evens, and then non-imaginaries for odds. Yay? Okay, so the process is basically the same. All I'm doing is throwing in different indices at you. Yeah? All right, here we go. What's the index? What's the index? What's the index? It's a 2. So in this one, we know the index is 2. Yeah? Which means you have to pull out groups of 2. Okay? Okay. Just like before, just break down the 294. 294 is 2 times. What is it? What? 47? Is that right? Yeah? That's no longer odd, so does 3 go into 147? Yes, it does. That's 3 times 49. Very good. And 49 is 7 times 7. Yay? Okay. So it looks like a 7 comes out of the group. We have 1, 2, 3, 4 X's. So there'll be 2 groups of 2 there. There'll be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Ooh, there you go. Y's. So groups of 2 are 3, and 1 will be left over. And then there'll be 2 Z's, and 1 group of 2 is left over. Yay? So outside the house is 7x squared y third z root 6y. Yeah? Oh, it's a square root, by the way, so you still missing that half a point? Oh, goodness. Yeah. Yay? So the reason I broke it down again, just to remind you that the index tells you how many groups come out at the same time. So compare that with the next example. Right here. What's the index? What's the index? 3. Yep. Here we go. Whatever index is 3. Okay. Break this down into prime numbers again. Does 2 go into 375? No. Does 3 go into 375? It does. 3 times what? What is it? 125. Ooh, does 3 go into that one? Nope, but 5 does. That'd be 5 times 25, and 25 is 5 times 5. Yay? Since my index is 3, I need a group of 3. So there's 3 5s. Come out. Yeah? For the x's, there's 1, 2, 3, 4, 5, 6. So there's a group of 3, and there's a group of 3. And y has no group of 3. Yeah? Since a cube root is not plus or minus, so you just take the numbers as it is. We have one group of 5, x squared inside the radical, 3y squared. Oh. Don't forget the cube root there. Yeah. Don't forget the cube. That'll probably be the biggest mistake because you left the index out of it. Yay? You good? Okay, so the first 2 I showed you how to do by hand. The next 2, let's do it. Go ahead and try to use the calculator for it and use our new move, right? So for example, if the index is 3, you're dividing 3 into 6. So 6 divided by 3 is 2. That's why there's 2 x's that come out. So the index just divides into the exponent. Yeah? Okay, here we go. Next one. What's my index? That's my index. 6. Yeah. Okay, so here's how to use the calculator for this. 288 is the number divided by x to the 4th. All right. Yay. Yeah. Okay. Enter. There it is. All right. So how about if I hit graph? Oh, nope. Why are you doing this to me? What did I do? Okay. I think the second. Not math. Okay. Gosh darn technology. Okay, here we go. Y equals. Is it 288 divided by x to the 4th? Sweet. Second table. Yay! Okay. Here we go. So 2 and 18 is a possibility. And that's the only possibility. Yeah? Okay. So one way we can break this down is break them down into like different parts. So you could also just break it down into 4th root of 288 times the 4th root of x to the 5th times the 4th root of y cubed 4th root of z9. That. So it was 2 and 18. So the first one is 2 4th root of 18. How many times does 4 go into 5? Once, and there's 1 left over. So this would be x 4th root of x. Yeah? That one doesn't work out. But how many times does 4 go into 9? Yeah, so z squared 4th root of 1z remaining. Yay? Everything on the outside can come together. So 2x z squared. Yeah? And then 4th root of. Everything that stays inside just stays inside. So 18x y cubed and then z. And then since it's 4th root, there's more than just plus or minus, so you could leave the plus or minus out. Plus or minus just for the square root part. Yay? Going too fast, too slow, or just right? We're good? Okay. All right. Next. Talk to me. It's true. So what happens when you take the square root of a negative? Pull out an I. Off the sauce. Alright, so if you break this up, it's square root of negative 54, square root of x to the 4th, square root of y to the 5th, and square root of z to the 7th, right? Negative 54 is going to have an I. When you divide by x squared, what do you get? 3 and 6. 3 and 6, right? 9 times 6 is 54, yep. So 3I root 6. Is that right? How many times does 2 go into 4? Twice. So this is just x squared. The other one is y squared root y. Very good, because there's 1 left over. How many times does 2 go to 7? 3 with 1 left over, so z cubed root z. Since it's a square root, you do have to have the plus or minus in front. Everything on the outside is 3i x squared y squared z cubed root 6 y z. Yay? Yay. Alright. Next! Alright. Cube root of negative 54. Let's do that one. Okay? For this one, since it's a negative, do you take the cube root of a negative? Yes. Alright, so on your y equals, you can just, you don't even have to worry about, well, I don't know, don't worry about negative 54 part. Here we go, clear, yeah. Just go 54 divided by x cubed, and let's see what happens. Answer is yeah, it's 3 and 2. So what I would do is pull out the, I wonder if you do negative 3. What would you do for negative 54? Yeah, so it's x to the 3rd power, so what's negative? The 3, the 2, or both? The 3 that's negative? So there's, okay, so pull out negative 3. But so if you put it to negative 54 like this, divided by x to the 3rd power. The only reason I'm double guessing myself. There we go. Yeah. So put negative 54 divided by x to the 3rd power. All right. So it tells you it's 3 and negative 2. Yeah. If you go up, you're right. If you go up, it could be 3. But here's the deal. When you square it, so here's my issue with it, is when you square it, negative 3 squared goes back inside. That's positive 9. So it'd be, which one is it? Oh, that's right. That's right. It's not negative 3 squared. It's negative 3 cubed. So negative 3 times negative 3. So it'll work out either way. Okay, perfect. Excellent. So this one is negative 3 cube root of 2. Yay. 3 goes into x to the 3rd how many times? Once. Yay. 3 goes into 7 twice with 1 left over. So y squared cube root of y. And 3 goes into 4 one time with a remainder of 1. Okay, so cleaning it up, it'd be negative 3 cube root. Oh, sorry. My bad. Negative 3 x y squared z cube root of 2 y and then z. Yay! That's good. Okay. Next. Oh, a 5th root. Yes, love. Uh-huh. thanks for that. Cube roots, do you need ice? Nope. Yep. Yep. All right, excellent question. Oh, fifth root, it's finally something interesting. Fifth root of 1944. Divided by x to the fifth. Sweet. It's not negative, so let's put it a positive. Oh, that's it. That's it. 3 and 8. Yay? Okay. So the first part of this would be 3 fifth root of 8. X to the 20. X to the 4th. Y to the 19. Third fifth root of how much is left over is 15. So 19 minus 15 is 4. So y to the 4th. And then fifth root of z to 6. So a z. Yeah. 0 to z. Yay. So 3x to the 4th, y cubed, z fifth root, 8 y to the 4th, z. Alright, let's get a little bit more interesting, shall we? There we go. Yes! Yes! Alright, here we go. When it comes to multiplication and division, what I recommend is to combine first and then simplify. You can simplify then combine, but chances are you'll have to simplify. So let's do it in 2. So if you multiply it out first and then simplify, you're good. Okay? So for example, yeah. All right. Here we go. I would definitely just simplify it out, multiply it out first, and then simplify as much as you can. So by multiplying it out, you just multiply outside to outside. So this thing, which is x to the y. Yes? And then inside to inside. So this and this. What's up? Is that right? Oh, is a negative 3 inside the square root? Yeah. Yeah. Okay. Because you're not taking the square root of negative 3. Yay? Okay. 6 times 21. What is it? Yeah, it is. X, Y squared. Yay? Okay. Here we go. Since we have a square root, it helps if you remember that you're multiplying it to whatever's on the outside. So I like to put the parentheses around it to remind yourself that whatever you do to simplify it, you just multiply it to what's on the outside. Okay? So, keeping the outside the same, y. Simplifying the square root of 126. What is it? It's a 14? That's cool. So a 3 comes out, and we know we're going to have a root 14. Yay. A y comes out. Very good. And then the x stays on the inside. Joy? Okay. Now just multiply it out one more time. So simplify it and multiply it again. Yeah? It's just outside to outside. So whatever's outside the square root, it is what it is. So what do we got? Negative 18. X to the 6th. Y squared. Root. Okay. And then for this one, I wouldn't worry about the plus or minus because there's already a negative on there. So when you're doing multiple things, like adding and subtracting, multiplying, and dividing, don't worry about plus or minuses, only if you're simplifying one radical. Okay? Okay, let's do it again. Here we go. Okay. All right, so make it one big cube root. Let's make it one big cube root. Here we go. 80 and 75. 6,000 x to the 7, y to the 6. Cube root of 6,000. Say something about the calculators, really? Cube root of 6,000? What is it? 5 and 48? Do we agree? Was it? 10 and 6. I think 48 could have kept on going down, right? So 10 and 6. So it'd be 10 cube root of 6. How many times is 3 going to 7? Was it? Twice with 1 left over. And then y squared. True? So 10x squared y squared cube root of 6x. Do I need a plus or minus for this one? No. Good to go. Here we go. Last couple. Questions, comments, concerns yet? All right. What? Jackson, did you say fraction? Yeah, I did. Yeah, I did. Jackson said fraction. Here we go. Just like before, I definitely reduce inside the fraction before taking the square roots. Okay? For example, over here, does 7 go into 189? Yeah, it does. What is it? What is it? 27. And then in division, what do you do with exponents? Subtract. 7 minus 2 is x to the 5th. Sweet. 27 is 3 root 3, right? X to the 5th is x squared root x. So final answer, 3x squared root 3x. Plus or minus? Yeah. Plus sure. Plus sure. Yeah? Okay. Last one. Whew. Finally. There you go. Ah. Alright. Alright. 4 over 32. What is it? Is it 1/4 or 1/8? Yeah. Here we go. So the 4 over 32 is going to be 1 over 8. Yeah. The x to the 4 stays at the top. There's a y and a c to the 6 at the bottom. All right. Here we go. If you want to split that up into 2 cube roots, you can. Basically, you're taking the cube root of x to the 4th at the top over the cube root of 8y c to the 6th at the bottom. Okay? Now play it. What's this one? Yeah, x cube root of x at the top. Right? Cube root of 8, 2. Yeah? And then cube root of z to the 6 is z squared, but we have a cube root of y still to contend with. All right. If the directions say to rationalize the denominator, you got to multiply it so that there's no more radicals in the denominator. Since there's a cube root right here, y to the second, right? Because we need 2 more cube roots of y to get it out of there. So if you multiply the top and bottom by y squared, right here, then you'll have y to the 3rd power, which cancels it out. Let me write it out. There you go. Because we have we have one y, right? And it needs 2 more to get out of the root. So this becomes the cube root of y cubed. Yay? Right? And the index cancels out the radical. So the bottom is 2z squared y. At the top, you're going to have x cube root of xy squared. Like so. So if you want to cancel out a radical and it's not a square, you got to multiply it by however many more you need to get out. Okay? All right. How are you feeling? Yeah. Sorry this was long and dragging out. Hopefully you get through the gallery walk. Take a look at the top of your paper. The number that you have is where you start. Odds do odds, evens do evens. When you're done, go ahead and pick up the bingo. Tomorrow is the quiz. Okay? All right. Let's go.